So, you look at this word, stoichiometry, and you're just kind of like, what is that, you know? You're like, stoichiometry? Only word I know from that is stoichiometry? It can't be. Well, you already know. Your first initial instinct is Google. And it seems like it's not just me that I can relate. But when you look up something on Google like stoichiometry, you always end up with those long, big word explanations that leave you kind of clueless, you know? And then you're basically forced to look up the definition, right? So you scroll down and you scroll through and you find Khan Academy, which apparently is a good website. And you read and you find out this. Stoichiometry is just using a balanced chemical equation to calculate the amounts of reactants and products. Oh, that makes more sense. Well, today we're going to show you a real-world example of stoichiometry, airbags. But before we start, we have to make sure that you know the steps on how to complete a stoichiometric problem.
In order to solve a stoichiometric problem, you must first balance the equation. Then you need to find the molar mass. Afterwards, convert volume to moles, write the conversion factors, do a mole to mole ratio, and then convert from mole to gram.
Okay, so in order to calculate the mass in the mole of sodium azide needed to produce 67.65 liters of nitrogen gas, we need to first take 67.65 liters and multiply that by 1 mole of nitrogen gas. Then we divide that by 22.4 liters, which is the molar volume. That would give us 3.02 moles of nitrogen gas. From there, we would do the mole-to-mole ratio, which would be 2 moles of sodium azide divided by 3 moles of nitrogen gas, and then multiply that times 3.02 moles of nitrogen gas to get us 2.01 moles of sodium azide. Then we need to find the molar mass of sodium azide, which would be 65.0099 grams per mole, and the equality would be the same, just without the mole. Finally, we would take 2.01 moles of sodium azide and multiply that by the molar mass of sodium azide, then divide that by 1 mole of sodium azide to get us 130.7 grams of sodium azide. To calculate the mass in the mole of sodium formed when 67.65 liters of nitrogen gas is produced, we need to do the same thing basically. Take 67.65 liters times 1 mole of nitrogen gas and divide that by 22.4 liters to get us 3.02 moles of nitrogen gas. Then we do the mole to mole ratio again. 2 moles of sodium divided by 3 moles of nitrogen gas times 3.02 moles of nitrogen gas to get us 2.01 moles of sodium. Then we need to find the molar mass of sodium, which would be 22.9898 grams per mole. The equality would be the same. And finally, what you would do is take 2.01 moles of sodium, multiply that by the molar mass of sodium, then divide that by 1 mole of sodium to get you 46.21 grams of sodium.
Airbag production involves the use of sodium, which is a very reactive metal. It works to form sodium hydroxide after reacting with water. If this chemical entered your body, such as your eyes, you could potentially become blind if you don't seek help immediately. For this reason, manufacturers remove sodium from the reactant site. To prevent maximum chemical exposure, airbag manufacturers mix the sodium azide with other chemicals that will react with the sodium and in turn make less toxic compounds.
Proper disposal of an airbag is crucial to human safety. If disposed improperly, you could seriously get injured. Habitually, airbags are recycled in accordance to the EPA guidelines. Any container used should also be properly disposed of in recycling.
In order to sell the product, we would begin an advertising to our target audience. Also, we would make sure that the consumers are aware of the potential risks that come along with an airbag. In addition, we would provide them with the guidelines necessary for them to follow if they ever have to dispose of it.
Thanks for watching, guys. And yes, we did this last